Hello, it's me again. I'm Nafid Salama. In this short video, I will explain what is the multi-chassis lag or VSX-LAG link aggregation. We already have established in the previous video the VSX stack between core 1 and core 2. We will verify that operation. Then we will configure link aggregation using LACP on the edge switch. And then after which we will configure the multi-chassis lag. The order of configuration doesn't matter. And then we will also configure the virtual gateway, which is they call it next hop virtualization. And after which we will verify the operation. We're going to create a VLAN, and then in that VLAN we will assign a virtual gateway IP address on the core 1 and core 2, and that will mimic a situation where the client, if there's a client connecting to edge switch or switches, and the DHCP server leasing out an IP address, that should have the default gateway equals to the virtual IP address, and that is what's so called virtual gateway feature that will substitute the VRRP, the need for VRRP or HSRP, and any need for the spanning tree in this case. So let's go. So on the edge switch, we will configure a normal link aggregation. We could use obviously link aggregation that is dynamic using LACP, or we can use as a static. In this example, we're going to use a static. And the interfaces that will be members of the link aggregation will be interface 1/1/1/1 and 1/1/2. So we're going to start and begin with creating the interface. I'll give it a value 1, which is the interface ID 1. Now that interface is where we configure stuff on it. So we're going to configure that interface as a trunk port. Before that, we would like to add the interfaces that will be members of that interface. So we can go exit. LAG 10. So they have become LAG 1. So have become members of LAG 1. We can say show run current context. We can see that these two are in LAG 1. We will exit this and we're going to go interface LAG 1, then VLAN trunk permit allow all. So we need to make it a layer 2. So we're going to go no routing, and we're going to go VLAN trunk allow all. So we can see, or we can view the show run current context. And if we show run interface 1/1/1 is going to be a member of LAG 1, and also that same applies to interface number 2. So now these two interfaces are members of LAG 1. What we will be doing, we will create a VLAN. Let us say VLAN 11, interface VLAN 11. We will give it an IP, and that will then we will test the connectivity to the VSX stack. Show run current context. You can see this is the IP address of that VLAN. These two interfaces 1 and 2 are shut down. If you issue the no shutdown command on the lag, that will not bring it up. You have with the shutdown command, you have to do it or apply it on the physical interface. So we're going to go interface 11/1112 no shutdown. We also need to no shut down the lag interface. So we go to interfaces, interface lag 1. We have to issue command show no shutdown. So we have no shutdown interfaces that are members of the lag, as well as the lag interface itself. We configure the lag as a trunk port. If we issue the command show interface brief, you're going to see these two interfaces up. We're going to see the lag itself is up. Now we see the VLANs or the members of that interface or these interfaces also are up. Now if we try to ping VLAN 11 IP, we should get a response. So locally, interfaces are up. Locally, VLAN 11 interface is pingable. So number one, we created the lag. Number two, we made interfaces members of that lag. We no shut down interfaces on the physical interface. We issue that command. We also go to the logical interface, the lag one in this case. We made it as a trunk, permitting all VLANs, allowed VLAN all. And we also no shut down command on the lag interface. So on the edge switch now, this lag has been configured correctly. Now, because this is static lag, it doesn't send any LACP hello messages. No LACP data units will be sent. And that's why it doesn't really matter locally. It will not check the other side, even though now the other side of the lag is not yet configured. We can see it's locally correct and it doesn't really check on the other side. So now we will go and configure the multi-chassis lag on core 1 and core 2. Okay, so this is core 1. Remember, the VSX stack is active. We can issue the command show VSX status. It tells us operational, in sync, everything works. So on core 1, we're going to create the multi-chassis lag. We will give it a lag 1 also as an ID. It doesn't have to match between edge and the core in this case, but it's a nice idea to just, I like it to match basically, but technically it can be any ID, locally significant only. And we're going to make this one multi-chassis. That's the extra command. And we will do no shutdown, no routing, and in the same time we're going to VLAN trunk allowed all. And that's what we're going to do here. Now we would like to make them member to that multi-chassis lag, and the link or the downlink between the core 1 and core 2 to the edge 3 in this example is on interface 1/1/5. So go interface 1/1/5, and we're going to say lag 1. I'm going to say no shutdown. So now on core 2, we're going to do something similar to what we've done on core 1. Show run current context. We can see these are the configs on that lag 1 interface on core 2, which is the secondary member of the VSX stack. And I can issue the command now. I need to go to interface 1/1/5 and make it a member of lag 1 and no shutdown. Show interface brief in here. We can see lag 1 here, and we can see is trunk is enabled, yes. Status is blocked. We're going to see why. It's blocked here. We need to find out why is it blocking. Even though it's not shut down, but it's blocked. So we're going to go interface lag 1 LACP mode active. We will configure them as active mode, and we will also do the same because we look at this one, says out of sync. It's blocking, and I issue the command show LACP interface. It says out of sync, so we will go interface lag 1 LACP mode active. So we go back to edge 3 switch, and if we go, that's a lag interface. We're going to configure this one LACP mode active. Show run interface lag 1 LACP mode active, no routing, no shutdown, and the same. And we're gonna have a look at the local interface here, interfaces. Show interface brief. The lag 1 now is up and running. Notice that because this is a multi-chassis, the lag speed or the bandwidth here is still 1 gig. On the other hand, on the lag, which is the edge switch, the lag is 2 gig. And the reason this is local on the switch edge 3, and the lag has two interfaces locally, so they are connected together, i.e. bound logically. They form a logical interface, and the speed will be twice because you have two links, interface 1/1/1 and interface 1/1/2. On the other hand, we're going to configure VLAN 11 in here, and we're going to double check show trunk, show interface trunk. We'll see that. So we will configure VLAN 11 here. So we're going to go VLAN 11. Configure the VLAN 11 also on core 2, which is the other member of the VSX stack. We will also configure the active gateway into in this VSX stack. So inside VLAN 11, we will go active gateway IP MAC address. We will create a MAC. Then active gateway IP 10.1.11.1. We will do something similar to this one on core 2 switch as well. So we're going and that should be the IP. Usually this is the IP address where the client pickup will be the default gateway for the clients. On edge 3, we will verify that we can ping the active gateway on the multi-chassis lag, which is the VSX stack. And it is there. And if we verify the MAC address, what the edge 3 can see, you can clearly see that it sees the virtual MAC for the virtual gateway, which is the active gateway. And it does see also the physical MAC for each individual switch. This is individual switches. These are individual switches MAC addresses. And this is the virtual MAC. If you go back to core 1 and verify the MAC address, you're going to see this is the MAC address. That's physical MAC. And for core 2, that is the physical MAC. We could see it. And if you look into the interface VLAN 11, you're going to see the virtual MAC that is also visible on the edge 1. So interface, we can show run interface 11. That's the virtual MAC. And we could see this virtual MAC here as well.